Welcome to The Explainer. Today, we're looking at a company that promises to solve traffic, but is actually digging into something far, far more complex. We're talking about The Boring Company. You've probably heard of their underground tunnels, the whole promise to just completely bypass rush hour gridlock. But when we actually look at the data, the engineering choices, and the business model, well, a completely different picture emerges. Okay, let's dive into this. What if these tunnels aren't just roads? What if they're actually physical servers for artificial intelligence? Seriously, think about it. What if the goal isn't just moving cars, but feeding a massive, perfectly controlled data loop? Layer 1, the New City Laboratories. To really understand this, we have to look at the recent Tunnel Vision Challenge. Out of 487 applications from cities all over the map, they didn't just pick one winner, they picked 3. And they are strategic laboratories. Take Dallas, specifically the University Hills Loop targeting South Dallas, where commutes can take up to an hour. By framing a project around infrastructure equity and economic development, they effectively build a strong political shield. Then you've got Baltimore and New Orleans. These are essentially ultimate engineering stress tests. Baltimore has this really dense underground packed with aging 100-year-old pipelines. And New Orleans, soft soil, high water tables just meters below the surface. If they can drill cheaply there, where traditional costs would normally double or even triple, they completely silence any technological skepticism. And how do you actually convince a skeptical mayor to let you dig under their city? Well, you give them a foolproof pitch. We did it in Vegas. We can do it in your city. That successful 1.7-mile Las Vegas Convention Center loop, that serves as the ultimate tangible proof of concept. It literally allows them to walk into any city hall and point to a living, breathing, working system. Let's move to and see how this builds into Layer 2, the infrastructure monopoly. Once you have the cities on board, the economics become, well, shocking, to be honest. Just look at this stark disparity in construction costs. Massive traditional subways in cities like New York or San Francisco cost anywhere from $600 million to $1.2 billion per mile. Meanwhile, the Boring Company is coming in at $10 to $15 million per mile. Now, they achieve this massive drop partly by building much smaller tunnels, roughly 3.6 meters in diameter, so just enough to fit a Tesla SUV, compared to those massive 5.5 to 6.5 meter tunnels you'd need for traditional trains. That results in a staggering 90% cost reduction. We are looking at a 40 to 60 times cost gap. This effectively makes traditional construction players entirely obsolete. And the secret weapon behind this massive cost drop? Speed. While a traditional tunnel boring machine slowly crawls at maybe 150 meters a week, their new Proof-Rock machine aims to literally chew through the earth at a blistering 1 mile per week. So the crucial point is, the claim that this won't cost a single tax dollar upfront is actually a brilliant psychological lever aimed at budget-constrained governments. What's really happening here is a shift to an infrastructure as a service model. It's exactly like a Silicon Valley software subscription. Cities pay nothing up front, but they may trade away their planning autonomy and their underground technical data for the next 30 to 50 years. Citizens could go from being public stakeholders to subscription-based customers, potentially facing annual 3 to 5% fee increases, just like we've seen with privately operated highways. Which really leads us to ask, is this a genuine cost breakthrough, or is it a technological monopoly tool? Typically, a city spends $10 to $50 million over several years just on geological surveys. So when the Boring Company absorbs those upfront costs, they end up owning the entire underground technical data set. They essentially become the gatekeepers to underground access at a price point literally no one else can match. Now, let's peel back Layer 3, underground AI servers. This brings us to the true operational purpose of these point-to-point tunnels. Consider this analogy directly from the source material. Earthquakes are essentially a surface-level phenomenon. If there's a storm, you'd want to be in a submarine. Being in a tunnel is similar to being in a submarine. This quote perfectly visualizes the goal. It's not just about avoiding traffic, right? It's about creating an isolated, weatherproof, highly predictable ecosystem. And this brilliantly illustrates the why. Pedestrians, complex intersections, unpredictable weather. By moving underground, you instantly eliminate 99% of those chaotic real-world variables. The lighting is constant, the routes are totally predefined. The multivariable driving problem is basically solved overnight. So what you are left with is a high-speed AI training ground. These are one-dimensional data corridors.
Tesla can test its full self-driving software, like FSD version 14, and its future robotaxis, under perfectly controlled conditions at incredibly high speeds. We're talking up to 240 kilometers per hour. And they can do all of this without having to wait for complex, surface-level regulations to catch up. The tunnels are quite literally the perfect real-world AI laboratory.
Economically, this creates a massive shift. In traditional public transportation, labor, specifically driver wages, accounts for a massive 60 to 70% of operating costs. But if you achieve level 5 autonomy inside these highly controlled tunnels and completely remove the human driver, you completely reshape profitability. Vehicles can run continuously with dramatically lower costs, all while generating high-quality data with every single trip.
Which brings us to the final piece of the puzzle, Layer 4, the ultimate closed loop.
Let's tie this all together with a bit of a reality check. A standard metro system can move anywhere from 30,000 to 50,000 passengers per hour in each direction. The Boring Company's Loop, using 5-seat vehicles, currently achieves a real-world capacity of about 4,500 passengers per hour in Vegas. The data proves this is actually not a mass transit solution. Instead, it is a premium mobility layer, prioritizing individual speed over total transport volume. Which brings up a really fascinating contrast. On one hand, you have the marketing narrative in places like Dallas promising to solve transit equity for underserved commuters. But on the other hand, given the actual low capacity of these 5-seat vehicles, well, if the system ultimately primarily serves a small group of high-paying users trying to bypass surface congestion, the promise of social equity becomes a very big question mark. Now, what's really interesting about this slide is the sheer genius of the vertical integration. Think about it for a second. Traditional construction firms don't make cars. Automakers, they don't dig tunnels. And software companies definitely don't operate transit networks. But here, you have a totally closed loop. The Boring Company builds the tunnels. Tesla provides the vehicles. Full self-driving delivers the intelligence. Every single component reinforces the other, creating a unified platform that blocks out competitors and is nearly impossible to replicate. So we arrive at the ultimate test for these new city laboratories. The system offers unprecedented speed, huge cost-cutting, and a literal perfect environment for autonomous AI. But it asks for a massive trade-off. Are cities willing to trade public ownership and long-term autonomy for Silicon Valley speed? Because if the answer is yes, we are stepping into an era where every meter of urban movement beneath our feet might just be dictated by private, profit-driven algorithms. It's a fascinating, complex future and absolutely one we need to keep a very close eye on. Thanks for joining me on this explainer. I'll see you next time.